Hi everyone, and welcome to the second of two videos going through some past exam questions on Hess's law. So again, I said in the previous video, Hess's law questions always look the same. You get this little table with a few little values in it, and then at some point you end up with a blank space and it's worth 3 marks. It's completely predictable. So this is definitely a Hess's law question. You can tell just by looking at it. Okay, so what do we mean by enthalpy of combustion? We've just got a definition to start with. So it's the enthalpy change when 1 mole of a substance is completely combusted. And the key things here are you got to have 1 mole of your thing, whatever it is, and it's got to be complete combustion. That's where you get your 2 marks from. Okay. Right, then it says here, the enthalpy change of formation of glucose cannot be determined directly. Okay, so this is what we're trying to do. Yeah, this is the enthalpy change of formation. We're forming 1 mole from the elements in their standard states. Suggest why enthalpy of formation cannot be determined directly. There's a few different answers you could give here. One is that, if we react carbon and hydrogen with oxygen, it's not going to make glucose, is it? This is just going to burn, right? You're just going to burn the carbon and hydrogen, you're going to make carbon dioxide and water. It's not going to make glucose. But that's an answer that's kind of specific to this question. If you wrote that would be absolutely fine. You'd get the mark for that. But I want to just talk through a couple of answers that would apply to any reaction, because you could get this question with any number of reactions. So what you could say is maybe this reaction is just not really a sensible one to do. So it could be because the activation energy is too high. And this is something that you can put for any reaction. So the rate of reaction is very slow. So it's not that you cannot do it, it's just that you can't realistically do it because you'd be waiting there for ages and ages for the reaction to happen. It's just not practical. Okay, and then this is the bit where we actually have to use Hess's law, use the values in the table to calculate the enthalpy of formation of glucose. Okay, so that's for this reaction. So let's write this out. Again, I'm going to skip off the state symbols because they're not relevant to the calculation. They are relevant if we have to write the equation out. That's super important, but for the calculation here, they don't really matter. Right, and then let's look at what information we've been given. Okay, remember, it's not really what we've been asked about that's important, it's what information we've been given. We've been given enthalpy changes of combustion. Okay, so combustion means take this substance and burn it. Okay, so therefore, when we come to draw our arrows, the arrows are going to point downwards because we're starting with these chemicals and we're burning them. We're not making these chemicals. Okay, do you see the difference? If we had enthalpy of formation, you'd be saying, how do I make these chemicals? And no, we're starting with these and burning them. And so you burn this, and you'd get some amount of CO2 and water. Okay, now let's put the values on. So we've got carbon is -394, so that's going to go here. And I need to times that by 6. The hydrogen is -286, and I need to times that by 6 as well. There is no value for oxygen because you can't do combustion of oxygen. You can't burn oxygen in oxygen so that it reacts with oxygen. It doesn't make any sense. So there is no value for that. And then glucose here is -2801. Okay, so then let's see if we can work out how Hess's law is going to work here. Let's label these up. Let's call this A and B and C, like we've done before. And then can we find two roots that are the same? So if we start here, I could either do B or I could do A and C, and that would get me to the same place. Okay, so we can say that B is equal to A plus C. Yeah, start here and go there, or go there first and then go there. But A is the one that we want to calculate, so A would be B minus C, rearranging that equation. So therefore, The enthalpy change that we want is going to be B, so we need to add this up. So it's minus 394 times 6, minus 286 times 6, minus 4080. And then we need to take away C, so minus 2801. So we're going to have to add this on. Okay. So it's this plus 2801. And we get minus 1279. Okay. Lovely. Okay, let's have a look at a couple more questions. Here we've got a definition again. Actually, I mentioned this just a couple of minutes ago. Enthalpy change of formation. I think we've had this exact same question in the previous video, just linked to a different reaction. So enthalpy change of formation is, hopefully you're getting bored of these types of questions by now, because you've learned them and you're like, oh, not this again. But these are good. These are, I mean, it's 3 marks. It's easy marks in an exam if you can bother to remember an equation, definition rather. The enthalpy change, sorry, what am I writing? It's the enthalpy change that accompanies the formation of 1 mole of a compound from its elements in their standard states. And then we need to state the standard conditions. We've done this before, haven't we? It's 298 Kelvin and 1 atmosphere of pressure. And again, we talked about you can change the units. You can do it in degrees C, 25. You can do it in 100 kilopascals, that's fine. Okay. Right, and here, finally, we actually have a Hess's law question that is a little bit different. Not much. We've still got a table with some values in it, and it's still worth 3 marks. But you can see they've drawn the cycle out for you, and it's not our normal triangular cycle. We've actually got a whole bunch of different steps in this, so this is a little bit different. So, you know, fair play to the exam board here. They're actually being a bit creative. Right, what's going on? Fill in the boxes on the enthalpy cycle with the correct enthalpy change values. And then calculate this. Okay, so we've got to fill the gaps in first. So we've got to try and match these up. So this is carbon reacting with oxygen to make carbon dioxide. So we've got to spot where is that happening. So let's find carbon and oxygen. So we've got carbon and oxygen here. So that could be it. That's the one we're trying to calculate, so it's obviously not that. Here I've still got the carbon and the oxygen. So that's not that process. Here I've still got carbon and oxygen. Right, this is the one across the bottom. Can you see here that I have carbon and oxygen, and at the end I end up with CO2. And the CaCl2 and the H2O have stayed the same. So I could cancel that out and cancel that out. And there you go, there's the reaction that I'm looking for. Okay, so that is this one. So this is the minus 393 here. Right, and similarly, we want hydrogen and oxygen making water. So let's try and find, where have I got hydrogen? No. Here I've got hydrogen. This could be it. Yeah, this is it. Look, so there's the hydrogen and the oxygen making water. Yeah, because I've gone from 1.5 O2 just to 1 O2. Okay. So again, here hopefully you can see the calcium cancels out, the carbon cancels out, and then I've got hydrogen and oxygen making H2O, and one of the oxygens cancels out. So that is this one. Calcium carbonate and acid making calcium chloride. Okay, this should be easy to spot. Where's the HCl? Here. No, it's not that one. Oh, it's this one. Calcium carbonate and HCl making calcium chloride water and CO2. That's this one. That's there. That's minus 54, which means this should go here. Let's just check it. Calcium and HCl makes calcium chloride and hydrogen. Yeah, here we go. It's this bit here, look. The carbon and the oxygen cancels out. There you go. So minus 168 goes there. Right, nice. And so now we need to calculate this one. So what we're looking for again is 2 roots. So we're starting here and we're ending up there. Okay. So if we're going from here to here, we can say that our enthalpy change, instead of just going straight there, we could do all the way around here, couldn't we? So it's going to be equal to minus 168 plus minus 285. Yeah, we're going to do that way, we're going to go that way, then we're going to go across here, plus minus 393, and then we're going to go here. But this is the opposite, isn't it? We're going to be going that way, so we're going to be doing the opposite to this process. So we're going to be doing minus 54. Does that make sense? Because we are actually doing that process, we are actually doing that one, we are actually doing that one, but we're doing the opposite to this one. So we're going to do minus 54. Okay, and then we just need to calculate this. So minus 168 minus plus minus 285 minus 393 and then plus 54 essentially. So we get minus 792. Okay, that's a little bit of an unusual one, but don't get freaked out. It's just the same as we've done before. It's just got more steps in it. Yeah, instead of being a triangle, it's this, I don't know, square or pentagon, you could argue. So don't be freaked out if they give you something a bit strange. You still use the same ideas as before.